Hi everyone, I'm hoping that everyone can hear me. I'd like to welcome everyone to the NRM Regions Australia Soil Carbon Basics webinar. My name's Rachel Clark and I'm the Knowledge Broker for Carbon Farming and the Emissions Reduction Fund with NRM Regions Australia, the national peak body for regional NRM organisations across the country. I'd like to start the webinar by acknowledging the traditional owners of the land where I am today. It's Ngunnawal, Ngambie and Narrego land in Canberra, and I'd like to thank the traditional owners for their careful custodianship of country for thousands of years. I'd also like to welcome any Aboriginal and Torres Strait Islander people who are joining us today. I'd also really like to welcome and thank our four fantastic speakers who I'll introduce properly shortly, and Rachel Morgan and Kate Forrest from NRM Regions Australia who are helping out with the webinar. Finally, I'd like to welcome everyone else, especially all the staff from regional NRM organisations across Australia for joining us. As you all know, we're here to take part in a webinar I've called Soil Carbon Basics. In all areas of carbon farming, there's a lot of legal and technical complexity, and I think soil carbon is almost the most tricky to get across. Anyone can see, or at least imagine, the carbon that is being stored in a growing plant or a tree, but it's not nearly so straightforward with carbon in soil. So I'm hoping this webinar will help to demystify this process and to also help people to understand the potential opportunities for carbon sequestration in soil in different areas and soil types across Australia. I hope you might also get a sense of the what's in it for me, whether that means improved environmental outcomes, increased profits, or a contribution to addressing climate change through storing more carbon in soil. I really hope this will be an interactive webinar, and I encourage discussion initially in the chat and then in the Q&A. So firstly, to our audience, we'd like to hear from you in the chat. If you could please tell us who you are and your organisation, if applicable, where you're zooming in from today. You might like to include what First Nations country you're zooming in from. You'll also find the chat at the bottom of the screen and you'll need to select all panellists and attendees to introduce yourselves. So I think Doug's mentioned his mic freezing, but yeah, if everyone else would like to pop in where they're zooming in from today, then that would be fantastic. Shortly, we'll also be asking you to start posting your questions and thoughts in the Q&A. The Q&A button's usually right next to the chat button on your screen, so feel free to ask questions, upvote questions, and provide answers and thoughts from your own experiences if you have some. Thanks everyone that started putting in where you're coming in from today too. I'd like to emphasise this is soil carbon basics. So there's no such thing as a dumb or obvious question. If there's a question you're hesitating to ask, you can guarantee it's one that at least 5 other people are desperate to hear the answer to. So please feel free to put your most seemingly obvious questions into the Q&A, and I'm sure many people will thank you for it. We'll be holding all questions until the end of the presentations, so please start posting questions as soon as they come to you, and we'll get as many questions as possible. We'll get to as many questions as possible at the end during our panel session. If there are links and specific resources we don't manage to provide in our discussion, we'll send those around with the recording later. I'll also be encouraging people to fill in a very short survey at the end, just so you're prepared, so that we know how useful the session's been and whether there are things we could consider for future webinars. So, to support us in our quest to understand more about soil carbon, how it's stored and the benefits it can offer, we're joined by 4 expert speakers. Associate Professor Beverly Henry from the Queensland University of Technology, Sam Duncan, the CEO of FarmLab, Luke Senor, the Assistant Manager of the Savannah Agriculture and Soil Team at the Clean Energy Regulator, and David Allen, a beef, sheep and now soil carbon farmer from the Corangamite region in southwestern Victoria. All our speakers today are playing a unique role in the early understanding of how soil carbon farming can work in Australia, so I'm really delighted they've been able to join us. So now I'd like to turn to introducing our first speaker. So Beverly, you can think about sharing your screen now. And that's Associate Professor Beverly Henry from Queensland University of Technology. Beverly Henry has been involved in research, policy and industry roles across agriculture and land use sectors for 30 years. Her work has largely been in the areas of climate change, climate variability and environmental management in Australian and international research and committees. Thanks so much, Beverly.
I just need to unmute, excuse me.
You're unmuted now.
Okay, thank you. And can you see my screen, Rachel? Okay, good afternoon. Thank you, Rachel, and good afternoon to everyone. Firstly, I'd like to acknowledge the First Nations people of the land from where I join you today. These are the Bundjalung people, and I pay respects to the elders, past, present and emerging. I also acknowledge all other First Nations people online and wish you a great NAIDOC week. So I've been asked to speak to you today about the basics of soil carbon, what it is and how we can keep it in the soil. I'm not going to get into the details. I'll leave that to the experts that follow me as well. The first thing I'd like to, the first thing I'd like to do though is to note that while soil carbon's getting an awful lot of attention at the moment, and mostly in relation to soil carbon sequestration and offsets, and also to some extent to address climate change mitigation and soil health for food security, it isn't new. Soil carbon has been of interest for hundreds of years. Farmers and gardeners have been very aware of the importance of soil organic matter for a very long time. And it has been the subject of a lot of research, including some critically important long-term trials established at research stations, some as long ago as the 1840s. And these are providing some of our best records of what soil carbon is and how it cycles in soils. So there's a lot of science underpinning what we know, although there are still some questions to be answered. Initially, the focus was on understanding how soils and atmospheres support plant growth for mainly for agricultural and food production reasons. And this remains, of course, of fundamental importance, but I just wanted to illustrate the rapid growth in interest in soil carbon. The two graphs on the bottom of this slide show the growth in number of papers published on soil carbon sequestration and the number of publications on soil health. So this is the basis for a lot of the interest that we have now. And no doubt some of the stuff that I present will be very familiar to a lot of you, but I hope it's not too basic, and I hope it helps to get us all on the same page for the presentations that follow. So what is soil carbon? I mean, firstly, soil is of fundamental importance to life on Earth. More than 99% of human food starts with the soil. Soil also stores a huge pool of carbon. It's estimated that there's around 2.5 billion combined. So soil carbon within the soil is important to the chemical, physical and biological functions that soils perform. And soil carbon includes both inorganic and organic carbon. So the inorganic carbon is largely the carbon that's held in carbonate minerals. It's much more stable than organic carbon and much less influenced by management. I'll talk very little or probably not at all about inorganic carbon, but I'll focus on the organic component. So what is soil organic carbon? We talk about it a lot, but one of the issues is that it's not always used consistently. I think there's some confusion that arises from the fact that we don't all talk about the same thing when we talk about soil organic carbon. Soil organic carbon is not plant litter on the soil surface. It's not buried plant residues or bits of roots that are fairly large. Soil carbon is the carbon that makes up about 58% of soil organic matter in the component that's up to 2 millimeters in size. So it's something that is measured in a very specific way and accounted for in a very specific way. And because of the way we need to think about soil carbon, we just have to look a little bit to start with about how it's measured. So because it's only in the less than 2 millimeter fraction, soil is firstly sieved. And that removes the larger bits of organic matter that isn't counted as soil carbon. It also removes the gravel. And if we're wanting to account properly for soil carbon, we also remove any inorganic carbon chemically. So what's left then is bits of plant biomass that have been, that are partly decomposed, root exudates and material like that, and dead material that, dead microbes and soil fauna that are also decomposing that are fed on these materials. If we want to reliably measure the change in soil carbon, we also have to measure soil bulk density. And that enables us to compare like with like. So if you're looking at a change over time, you have to compare the amount of soil carbon in the equivalent soil mass. And this is a little technicality, and Luke will probably touch on that later with relation to accounting for under the Emissions Reduction Fund. So within the soil, organic matter is subject to physical and chemical transformations, and from that you get a continuum of forms that make up about 1 to 5% of Australian soil. So it's quite a small amount. And this material cycles at different rates depending on the stage of decomposure that it's at. And if you look down the soil profile, most of the soil carbon is held in the top layers, in the top 10 centimetres or up to 30 centimetres. And this is largely particulate carbon that's fairly recently added and little broken down. As you go deeper in the profile, the material becomes more decomposed, smaller, and generally more stable. So sequestration, soil carbon sequestration requires the accumulation of the long-term storage fractions of soil organic carbon. And it's important to understand that. So if we look at the carbon cycle and how it gets into the soil to start with, and I do appreciate this is fairly basic, but you know, it's important to understand this, that soil carbon comes from the atmosphere. So plants take up carbon dioxide in the process of photosynthesis, and with the help of solar energy, they transform this into plant biomass, and this helps to, and it breaks down, helps the plant to function and to grow, becomes part of plant growth. It enters the soil through decomposing leaves and roots and also exudates. And as the microbes feed on it and it breaks down, respiration returns the carbon to the atmosphere as carbon dioxide. And up to about 80 to 90% of the carbon that's taken up, that's added to the soil through photosynthesis is returned in quite a short time, in a matter of months or a decade or two. This is a very important cycle. It releases nutrients for plant growth, and without that, we wouldn't be able to have the plant biomass in the first place. So nitrogen, phosphorus, and sulfur, nutrients like that are released in this process. But up to 10% or so of the carbon is not released in this short cycle, but is transformed and becomes protected in the soil in mineral aggregates. And that's the component that stays in the soil for a long time, is called sequestered soil carbon. And if we separate out these two in a diagram just for ease of looking at it, the particulate organic matter is the part that is near the soil surface generally and cycles fairly quickly. And the mineral associated organic matter that exists as sort of films around mineral particles, protected from breakdown by microbes and stay in the soil for a longer time. And that's the carbon that's kept out of the atmosphere and is called sequestered soil carbon. That cycle in a natural system ends up being pretty much in a steady state. So there's a little change over time in the amount of stored soil carbon. But once you introduce agricultural management, it adds a whole lot of complexity to this relatively simple cycle. So agricultural practices change the inputs to the soil. There might be organic amendments added. There's material removed through harvesting crops and through livestock consumption. The soil properties are changed by adding lime to change the pH, by cultivation, by irrigation, for instance. And that changes the activity and the diversity of soil microbes and also influences the cycling process. And both the slow cycling material and the stored carbon material are important, but they're important in slightly different ways. And we need to understand how management affects them. Just to look at this in a rather simpler way, the amount of soil organic carbon that is stored depends on the balance between the inputs and the loss of organic matter. And there are a number of factors that affect the rates of input and the rates of losses. And to change the storage, what we want to do, if we want to increase it, is to shift the balance in these processes more towards the inputs and less towards the losses. And we've already said that there are a number of factors that affect it and that management affects it. But a number of analyses show that the most important influences, the biggest drivers on the amount of carbon stored, are climate and soil properties. So if you look at this graph, it's a little bit complex, but this was a meta-analysis. So I looked at all the studies that had been done that looked at soil organic carbon stocks in soils in New South Wales, Queensland, Victoria. These are agricultural soils, and the variables that influenced how much soil organic carbon there was. And you can see that the biggest blue bars are aridity and clay. So aridity largely depends on rainfall, the amount of moisture that's available in the soil for plant growth, and clay is a soil property that largely determines the amount of mineral associated organic carbon. So they're the principal drivers of how much soil organic carbon is stored in these soils. And on the right side, and I've put a brown circle around them, there are three variables that do influence soil organic carbon stocks that are subject to management: pasture type, residue returns, and land uses. These have a smaller effect, but within the constraints of climate and soil organic carbon at any location, these management factors do influence how much soil organic carbon is stored. And it's important to know that we are able to change the amount of soil organic carbon, and it can be a positive change or it can be a negative change. And so we have to try to understand how this influence occurs to know how much change we can make to influence both productivity of the soils, the health of the soils, and its potential to add climate change mitigation benefits. We have to sort of think about how much we can change. What is the potential for soil organic carbon sequestration? There's a lot of interest in this question. From the last slide, and the influence that climate and soil properties have, it becomes clear that there are regional differences in how much soil organic carbon can be changed, and we have to bear this in mind. So not to extrapolate from one site to another too freely, because it's probably not going to work. This table here shows us the summary data from a meta-analysis of Australian field studies. So soil samples taken to a depth of 30 centimetres show that on cropland, on grazing land and land conversion, you can increase the amount of soil organic carbon. The amounts are quite small and they cover quite a range. The biggest changes there are for land conversion. So changing from a cultivated system to a permanent pasture clearly decreases the amount of disturbance of the soil, so the amount to which soil organic carbon is exposed to microbial breakdown, and it increases the continuity of input generally. So there is scope to manage the amount of soil organic carbon that is there. The amounts are small, and but they do cover large areas, so there is a lot of potential. But one caution that we need to bear in mind is that while we can get bigger rates of soil carbon sequestration than are shown in this table, but often they aren't sustained. So if you have a soil that is fairly low in soil organic carbon and introduce a positive practice, you can get a fairly rapid increase in soil organic carbon. It's making up for what has been lost before. So in the first 5 or 10 years after introducing a new practice, there can be a rapid increase in soil organic carbon. But it's incorrect to assume that that rate will continue indefinitely. What happens is that as the capacity to store carbon is taken up, you approach a new steady state that's determined by soil and climate in the area that you're in, and the rate will slow down. The rate of sequestration will decrease, as you can see in the right-hand side of those two stylized curves there. So that's one caution. There's another caution that I would emphasize too, and that is that Australia has a very variable climate. We have droughts, and obviously we have floods, as some people are experiencing at the moment. And the rate of inputs varies with the quality of the season, if you like. One study in New South Wales that was led by Warwick Badgery showed that 12 years of gains of soil carbon following the introduction of an improved management could be lost in 3 years of drought. So the gains occur sometimes pretty slowly, but that soil carbon can be lost again. The other caution I would say is that it's not a good idea to assume that sequestration that's occurring due to a management change can be multiplied up by the area that is potentially available for that change. It depends on adoption by farmers. And the changing practice is a big decision in farming, and it's best done with good information and a lot of homework, I suppose, behind it, because there are economic and environmental impacts from changing practice. So that it's important for farmers to be informed, and it's important for policy not to assume a certain level of adoption that can occur. An important decision. So the last point I'd like to make is that in looking at what is achievable under soil organic carbon management, we have to be aware that the knowledge is growing. We don't have all the answers. Initially, when scientists started looking at soil organic carbon, changing tillage to a no-till system was a good way to sequester more carbon for climate change mitigation benefits. It became clear that no tillage didn't actually always lead to soil carbon sequestration. This figure shows the additional carbon under a no-till soil situation compared to a conventionally tilled soil, and the zero line that you can see dotted there is a no change. So near the surface layers, there is more carbon under no-till. This is because of the greater inputs and it's largely particulate and rapidly cycling carbon. If you go down to a depth of 20 or 30 centimetres, there's more carbon under the conventionally tilled soil. And this indicates a redistribution that occurs when you till versus no-till. So 20 or 30 centimetres is below the plough depth generally. And that redistribution and the fact that there's very little change at even great depths means that overall there is often no or very little change in stored soil carbon in these systems. So there's two take-home messages from this. One is that the soil carbon that's increased near the surface soils is very beneficial for productivity and for soil structure and condition generally, but that it doesn't necessarily equate to soil organic carbon storage for climate change benefits. And the corollary to that is that measurement for soil organic carbon sequestration, the long-term storage, has to take into account a greater depth than the top surface layers. So a gain in the top 10 centimetres does not necessarily translate to increased storage over a longer time. So I've rushed through that a little bit because there wasn't much time and I've tried to fit in a lot. I hope that it hasn't been too confusing. And I'd just like to wind up with some summary points. Firstly, soils with higher organic matter are generally healthier and more productive. Soil organic carbon transformation dynamics are complex and soils can be a net sink or a net source, depending on how management is, but also depending on natural climate factors. Managing agricultural soils to improve soil organic content and dynamics provides many benefits. Rapidly turning over soil organic pools release nutrients for plant growth and improve soil structure and condition. Slower turnover soil organic carbon pools may also contribute climate change mitigation, but there are a number of factors around counting that as soil carbon offsets, which you'll hear more about in later talks. The practices that store soil organic carbon often have co-benefits for agriculture communities and natural ecosystems in terms of soil structure, water quality, a whole lot of ecosystem services. But it's important to be aware that there can be possible economic or environmental trade-offs when you change management for soil organic carbon. So adding irrigation may have implications for water costs, for instance, and water availability for other purposes. And it can also affect the business side of farming as well. So within climate and soil constraints, good management can increase carbon in soils, but maintaining that soil organic carbon is more difficult. It can be lost again. And neither the soil organic carbon nor the science of soil organic carbon storage and measurement are stable. We need to stay on top of the growing knowledge, and that's only will continue to develop. So with that, I would like to thank you for your attention and hand back to Rachel. Thank you.
Thank you so much, Beverly. That was really interesting, and I'm really looking forward to unpicking some of those muddier issues during the Q&A panel session after everybody's spoken. So thank you so much for your introductory talk there. Also thank the first brave person that's put a question into the Q&A. So this is just a reminder to put your questions into the Q&A and we'll get to them when all our speakers have had their opportunity to speak. So thanks so much, Beverly, and we're going to move on to our next speaker, Sam Duncan. Sam, if you'd like to get ready to share your screen. So Sam Duncan is the Chief Executive Officer of FarmLab. And I first saw Sam speak at a future farming conference that was broadcast from South Australia last year. Sam was the first person that had addressed some of the really key questions I had about how and where soil organic carbon could be stored. So I was really delighted to be able to get Sam to come along today. Sam's a passionate advocate for sustainable agriculture, a lover of the outdoors, and an Air Force veteran of 12 years. He founded FarmLab in 2016 with the hypothesis that if farmers had better soil data, they could better manage soil carbon. Since then, FarmLab has evolved into a sustainability company, helping farmers and their consultants collect and measure the environment using technology. Welcome and thanks so much, Sam.
Thanks, Rachel. You can hear me okay?
Yep, sounds good.
Fantastic. Well, thank you for squishing me between Beverly and Luke. So I'll be very careful about what I say today because I've just come after the science piece. That was fantastic. Thank you, Beverly. And Luke will tackle this from the regulator piece. We'll sit in between, and I'm going to try and make this as pragmatic as possible and as practical as possible for those farmers out there in the audience and those consultants out there in the audience working with these farmers. So what is FarmLab? Firstly, just to situate us, we're a software platform. We reduce the cost and complexity to run these projects for a consultant, to measure the soil, to run the incredibly complex clean energy regulator calculations. Sorry, Luke. Luke and I are on the phone every second day at the moment, trying to figure some some of these things out, and really just reduce the cost for farmers. Right now, they're quite, with complexity comes high cost, and so we're all about trying to streamline that. But more broadly, we're an environmental measurement platform. We give people a mobile app to collect samples, soil samples. We're moving into plant and water samples testing as well. We do biodiversity, so you can go out and collect bird calls and other bits and pieces and then map them. And the key thing here is that we believe, as Rachel said, that if people have better data and can better measure things, they can better manage things. And I think, Beverly had a really nice little into that piece there, which is the soil organic carbon. The science is developing and we're understanding more and more as we go about carbon and the environment more broadly. We really need the data to sort of back that up and to help us develop some of that understanding. So without further ado, I'll jump in. So what am I going to cover today? Look, I'll talk about the Australian Clean Energy Regulator methodology. I noticed there was a Q&A question there about how things are measured. I also will quickly reference other protocols just to situate everyone as to where Australia sits in the grand scheme of things. We'll look at some of the factors to consider when participating in a clean energy regulator soil carbon project, in particular carbon potential and what we're seeing across Australia. And lastly, we're going to look at modelling and soil carbon measurement into the future as some additional sort of up and coming things there, which we'll also tie into. So more to follow. So where do we sit as a protocol and as a method globally? Believe it or not, and I think this is a result, I'm sure Luke can provide some of the history here, but Australia has one of the most advanced carbon regulation and regulations in the world. What I've got here is a little summary provided by carbonplan.org. They are a not-for-profit that have assessed all of the different measurement and modelling methods available today globally. Many are voluntary markets, meaning that it's a private organisation that has a protocol. They're a standards body like Vera, like Regen Network, like Gold Standard, that have developed this method that has then been used and used to generate carbon offsets and sell carbon credits. Australia, as you can see by the 4 ticks there on the right, is probably one of the highest standards in the world. But as I said before, with complexity comes cost. So it is a little bit more expensive than some of the other standards out there, just in terms of the measurement requirements. I will just say that Australia has an estimated method which uses the FullCam model to estimate changes in soil carbon. It is effective, however, it's not as effective as the measured approach, which requires actual soil sampling. I can answer any questions about the, Luke's probably better to answer about the estimated method and the FullCam models, but it is out there. We don't see too many of our clients pick it up just because of the return on investment for the cost of entering the project versus what the client is likely to get, because it does have a habit of not underestimating, but potentially underestimating how many offsets could be generated over that time period. And so, yeah, majority of Australian ag emissions projects for soils generated under the measured protocol, and I'm sure Luke has the numbers on that, and if I'm wrong, please correct me. Participating in a regulator project. So we'll just touch briefly on what participating in a clean energy regulator soil carbon project looks like, and because Luke's going to go into this in much more detail. I had a brief look at your slides there, Luke, and I won't spend too much time on this because you'll cover this more accurately than I will. But 3 things to talk about. Given the complexity of measurement and monitoring compliance, most farmers use a carbon developer. It's why carbon developers exist today. You know, they're not just there to take your money and your offsets. They are there to simplify a lot of the compliance and the monitoring issues. There are a lot of complexities when it comes to this, and the regulations do change. So having somebody that you can work with that's up to speed on the latest changes is really crucial. We do sometimes work with farmers direct through the Soil Carbon Services Pack, but quite often it can be more efficient to work through a carbon developer. We work with quite a few of those. Secondly, Australia has a mass-based protocol which requires the measurement of soil and the estimation, either the estimation or the measurement of soil equivalent soil mass or soil mass when those measurements are undertaken. And then what does this mean? I think Beverly's touched on this in terms of how soil carbon is measured. We don't just look at the percentage. We also have to consider the content of the soil and the bulk density of the soil to calculate the amount of carbon being sequestered in that soil. So really important. What it means is, and I will refer to percentages later on, but you know, if you increase soil carbon by 1% in a soil with a high bulk density, you'll increase more carbon and generate more carbon offsets than if you increase carbon by 1% in a soil with lower bulk density, because there's more you're increasing you're increasing the mass of carbon, and this is what it's about. Lastly, with the simplification of measurement using software like FarmLab, some of our clients are turning to their agronomists to run these projects, and there's some socioeconomic advantages there, where a lot of farmers have really tight relationships with their agronomists and consultants. We are starting to see some consultants sort of take the place of the carbon developer and work with their clients to run these projects, which is exciting. I'm really excited about that. So let's just get into the first step around supporting registration and sort of what to look for on your own property, and if you are considering entering a project. So there are a few key things. We provide what we call a soil carbon offset report, which is a very general report. It's very cheap, but it's a desktop look at the farm, and what we cover off on two things in particular. There's a few things on the next slide as well, but essentially we look at ground cover change. We get this through partners at SIBO Labs, because it does correlate well with management practices as well as soil carbon levels. Now, so this is the graph on the left-hand side, and the farm that we've mapped is the blue farm, is the blue line here, and what we're seeing is the change in ground cover over time. And if there's a downwards trend, which there has been, particularly around sort of the drought 2016 to 2019, we can fairly reasonably accurately estimate that there's been a decline in soil carbon. And so this is really important. This is sort of looking at what helping a farmer and helping somebody on the ground link a management practice to a change in soil carbon. Obviously, this is looking at ground cover as that proxy for that change in soil carbon. So, we look at 2008 to 2012. Steady increase here in ground cover. The land manager can link that back to a practice that they may have implemented. And when we come down to what you should be looking at trying to do when you build soil carbon, quite often, what we can refer to the literature, but the literature is still developing. And quite often it's really good to link what the land manager has done in the past with the changes that they've had. And, you know, as Beverly said, a lot of this is due to climatic factors. So if you can remove that from the equation, you can build confidence, or the land manager can build some confidence around, all right, well, there was a drought there, so, you know, take that out of the equation. But I had a pretty steady period between 2008 and 2012. You know, median rainfall, pretty consistent, but I changed this and this was the effect. So really important, because what we're trying to encourage people to do is to generate, and where I think the literature falls down today is we don't have a clear insight on, you know, if I do X, what is the impact on soil carbon? If I do Y, what is the impact on soil carbon? And some of these things are still evolving, and it's causing a lot of, I guess, uncertainty in the industry right now. People won't enter until they can manage that risk, until they know what to do. We have annual woody cover change here, and this is really around land clearing. Primarily, this is used as a way to look at how much land can be used to sequester soil carbon. So we simply remove the amount of forested area greater than 20% canopy cover from the project area there. All right, so this was a little presentation. I've regurgitated this a few times, but this is great, because this what this graph here has done is we've mapped ground cover now to percentage soil carbon for a local farm in the region. I'm based in Anawan country, Armidale, New England, and this is a farm over in Uralla. So what we have here is the change in ground cover, which is the orange line. You see a decline, pretty steady decline there until 2019, versus carbon test results averaged. This is, if we got percentage carbon, yep, on the right axis here, averaged for that farm, and you can see a pretty steady decline over time. But really importantly, there is a lag effect here. So after ground cover has dropped, we see a drop in soil carbon levels. So really key to keep in mind is that there is this, obviously, and makes complete sense, especially after that fantastic presentation by Beverly. When you think about the carbon cycles there, you have to grow the roots have to decompose. Obviously, if you don't have roots last year, there may still be decomposition and cycling occurring, but it's usually sort of 12 months following that you start to see the decline or the increase. And so because of this, soil carbon projects often have this long sort of timeline. Could be, I think the regulation says between 1 and 5 years. Measurement should be done between year 1 and year 5. Usually we see it done around year 3 or 4, depending on what's happened in that time. Now, one of the key things that I have to address for Rachel is carbon potential across the landscape. And this was really hard. When I was putting this brief together, I was trying to understand, you know, what we're seeing. The challenge is probably 95% of projects, carbon projects, have been registered in the last 2 to 3 years. So they're yet to see an offsetting accrediting event. We are starting to see, you know, a few come up now with a few of our clients, and we're starting to see a few more. So it's really hard to actually gauge where things are increasing because of the events that are. We're seeing increases in soil carbon. They're, you know, few and far between. However, what I thought I might do today, naughty, but CSIRO have some look-see developments that we're currently working on them to assess and provide them with feedback. If anyone wants to be part of this, we're more than happy. Please reach out to me afterwards, and we'll give you access to the tool through us, because we have to provide feedback to CSIRO on this. And what they've done is essentially mapped the risk profile to increase soil carbon across the country. This map here is taken from the State of the Environment report, but it's very similar in terms of, it's very similar looking to what CSIRO are about to produce. And this is going to sit on top of the Look-See tool. So for those that have seen the Look-See tool, it's a carbon calculator that will estimate carbon for a polygon that you draw. And this is an add-on which is going to also tell you for that area that you've drawn out the capacity. So I'll just go through the little list there on the right. How full is the bucket? How you know, what's your potential to increase carbon? The gains index, so how much you can add to that bucket. So, you know, for one of these green areas, you know, you might have a max potential of 5%, but you might be sitting at 1% carbon, right? And then retention, which is about how likely you are to retain carbon based on climatic factors and a whole bunch of other things that CSIRO have put in there. And all of this is going to contribute to an overall carbon potential score. So like I said, we've got access to this tool. We're looking to sort of push this out and get some feedback on behalf of CSIRO, and it will help hopefully assess, hopefully make land managers, give land managers a bit more insight into what their potential is across the landscape. There. So some of the key things when it comes to understanding limitations, and these are some of the key takeaways for you to think about before you enter a project. Are you greater than or less than 300 mils in rainfall? If you're less than 300 mils of rainfall, very, very hard to sequester carbon. Between 300 and 400 mils, possible. Again, it's quite difficult, but can be done. Just looking at really emphasising some change in land management practices. We're here in New England, and a lot of our projects and clients are here in New England. With sort of 600-700 mils. I mean, this year it's probably been about 2,000 mils. It's been ridiculous. Not quite, but high rainfall and lots of potential. Available water capacity, and this comes back to that clay. That bar graph that Beverly gave before, we had sort of clay being one of the primary drivers there. Available water capacity is just I guess a more advanced way of saying clay content. Absolutely. Soil type is really, really key because you have to be able to grow those roots to sequester carbon. And the last one there is interesting. It's propensity to change or additionality, which is really tough, right? This is what management practice can a land manager introduce to sequester carbon. Rachel, how am I going for time? Sorry, I do have a timer in front of me.
You can have another minute if you'd like, Sam.
Give me one more minute and I'll fly through the rest, because I've covered off on all the really exciting things and can answer the rest. So I have a few slides here on how a project is registered. Luke's going to cover this in a lot more detail, so I'll just skip through. But basically, stratification, so you know where to sample. Submit that sample plan to Luke. Luke approves it, and it's then sampled and measured, nice and easy. And then we calculate the amount of carbon offsets, and we produce something that looks like this. And so this is the end result for a carbon project, where at T0, we had about 14,100 tonnes of carbon in the top 100 centimetres of soil. And this is really the number to beat. So when you enter a carbon project, this is sort of the first number. David Allen could probably talk about his experience. I know, having gone through sort of this baseline sample round himself, this is where a sample's come out, the project's been registered, and now he's got that number there, and he's now implementing some changes to hopefully increase this. What happens next is that then you go out in 3 to 5 years time, or 1 to 5 years time, and you remeasure after you've implemented these management practice changes, and you look at the difference. If we assume, just to give you some economics, because everyone loves everyone wants to know how much you can actually make doing this, right? We all talk about the environment, but there's also this other driver, which is revenue. So in this case, if we increase 0.5% carbon over 10 years, Beverly might balk at this. But let's just assume 0.5% carbon, and remember it's mass based, so that's converted using bulk density, and bulk density is going to change across the farm. If we can increase that over 10 years, which might be achievable, we ended up with an end amount of carbon of 17,800 tonnes. The difference between 17,800 tonnes and 14,101 tonnes is about 3,000 tonnes. Sorry, 3,000 tonnes, and then we multiply it by a constant of 3.67, which is the constant to convert CO2 equivalent from solid carbon. Then we subtract variance, which is an indicator of accuracy. I can answer this in the Q&A. We subtract any change in baseline CO2 emissions from that farm, most importantly. We then end up with the total amount of carbon, in this case, 10,654 tonnes of CO2. At a spot price, I don't think it's quite $50 today, but let's assume $50. We get a total revenue of $532,000 over the course of that 10-year project. Per hectare, $8,122 per hectare, or $812 per hectare per year over 10 years. I think that's correct as far as my math goes. Yep. I've looked at this enough, so I should be right. So that's sort of what it equates to. Now, that's if a land manager can get to that 0.5% increase. And the key thing is, I mean, this is all the easy stuff, right? This is all calculating it. But at the end of the day, somebody has to actually drive up carbon and do so consistently across their property. And that's about it. Bit there about modelling, but thank you very much. So thanks, Rachel. Sorry, I think I went a bit over time, but
No, perfect. Thanks so much, Sam. That was super interesting, and I really enjoyed all your maps. So thanks for showing that, sharing that with us, and also it was really interesting to have those figures there at the end. I'm sure people that are farmers, that are involved with farmers, really looking for some of that, some of those numbers. So thanks so much for popping those in. It was fantastic. I just reminded to everyone to keep your questions coming in. I have seen quite a few flowing in, so thanks to the people that are putting them in there. So our third speaker today is Luke Senor, the Assistant Manager in the Savannah Agriculture and Soil Carbon Credits team at the Clean Energy Regulator. So you can share your screen now if you'd like to, Luke. So Luke's primary role is the facilitation and regulation of soil carbon projects registered under the Emissions Reduction Fund. And this includes managing the registration, crediting and variation of any projects in the soil carbon space. So thanks for joining us, Luke. Oops, you're still muted, I think so.
Sorry, thank you so much. Let me bring up these slides. So thank you very much for that warm introduction. Luke Senor, the Assistant Manager of the Savannah Agriculture and Soil team at the Clean Energy Regulator. Don't let the name fool you. We also take on blue carbon. We haven't added that to our name yet. I'm sure it'll get there soon. I'm going to give you a very, very high level brief introduction into the life cycle of a soil carbon project. It's a little bit different to some of the other emission reduction fund projects that run at the CER. So I just wanted to make sure that everyone understood what their responsibilities are if they were to be a participant under this scheme. So first of all, we've had a few people mention that yes, there are two active methods for soil carbon at the moment, which is the 2015 method, which is model-based or non-measured, and the 2021 method, which was released at the end of last year. We have projects that are still registered under 2014 and 2018, generally, we expect most of those projects to transfer across to the 2021 method for reporting to take advantage of some of the advantages that the newer method has. This is a graphic that's thrown around our agency a little bit. It's very, very general pictogram about how the projects work. So you would identify the project that you want to run. For example, you want to register a project under soil carbon because you see a potential to sequester additional abatement in your soil. You apply to us to register the project. There's eligibility criteria that we assess. And then if the project is eligible, the project is then declared. From that point, you would deliver the project, which involves implementing your new activity, which I'll go into shortly. And then also taking your measurements. So that includes a baseline and a subsequent. You get that soil analyzed, and then you write the offsets report. You submit it to the regulator again for an assessment. And if there's been genuine calculated and measured abatement, you are issued carbon credits. 1 carbon credit is equal to 1 ton of carbon dioxide equivalent units removed from the atmosphere. You can then choose what you want to do with those carbon credits. You can sell them on the free market as a commodity, or you could sell them back to the regulator if you have a contract. And now I apologize, this slide does look a little small, but when you deliver the project, you're implementing one of the eligible activities that are stated within the method. So there's 13. They're listed there. Essentially what we're looking for is a new or material difference to what you did during the baseline, which is 5 years before you apply to register. So you can apply nutrients, lime or gypsum. You can undertake new irrigation, change your stocking rates, rejuvenate a pasture, or use a cover crop, provided that it's something additional to what you did in the past 5 years. Generally, we'll accept that as a new activity, and that's the activity that you will be credited on. And as also I mentioned, in that first reporting period, you'll need to do a baseline measurement to take the stock of the carbon that's in your soil at the beginning of your project. And then you'll have to do another sampling round to measure the increase between 1 and 5 years later. Now the report, this information is set out under the method. It's section 32 for those who are very interested. There are also generic provisions for all emission reduction fund offsets reports to be met under the Carbon Farming Initiative Act and rule. The reason why I bring this up is because we often have questions from individuals who want to run projects, and it's advised that if they feel that they are confident in meeting all of the requirements that a proponent needs to meet, you can. However, often we see project developers come along and assist those, and that can be a private commercial relationship between yourself and those providers. But it's just important to note that you would need an NRU account. You would need to be able to do your geospatial mapping of the project area and carbon estimation areas. You'll then have to implement the new activities, monitor the activities, arrange for the soil sampling and laboratory analysis, calculate the abatement and put in the offsets reports, and then also ensure that you can get at least three independent reasonable assurance audits over the 25-year crediting period. And again, if you've got a small screen, the effect is probably lost a little bit here, but these are the 69 equations from the method that are used to determine your abatement. A lot of them are about determining baseline emissions. Some of them are about determining the percentiles of the cores that you've collected. And the final red box down here is, once you have all this information, the amount of ACCUs that you're going to be issued for that reporting period. So if you have measured an increase in your soil organic carbon and you've put your offsets report in, this is just a very simple infographic about how many credits you're issued. So we have a baseline measurement, which is this much. And then there's been an increase in the amount of soil carbon stocks in this portion. And then we reduce the number of credits that you're issued by the increase in the project emissions for carrying out that project. Those reports have to be submitted within 6 months of the end of the reporting period. You decide how long those reporting periods are, provided they are longer than 1 year and shorter than 5 years. And these next few slides they're all very similar, but this is essentially the entirety of your crediting period. So there's some key dates here, and they're assuming a few things. One, you're doing your sampling at the very last minute, and two, you're using a 5-year reporting period. So if your project is declared on the 15th of February 2022, you can begin your new activity immediately, and then you're organized. So you've organized to get your baseline sampling completed on the 15th of March. You then have to wait at least 1 year to do your subsequent sampling, and the next round of sampling has to be completed within the first reporting period. So that's before the 14th of February 2027. Then your next reporting period will begin on the 15th of February 2027. You'll submit an offsets report and an audit before the 14th of August 2027. And then the CER may take up to 90 days to assess that offsets report and issue the ACCUs. If the first issuance of ACCUs is on the 14th of November, this is when your permanence obligation period begins. It's fundamental to the scheme that you are maintaining the carbon that you sequestered into the soil for that period of time. ramifications of not continuing the project activities or revoking the project because you no longer want to participate is that you may be required to relinquish some or all of the ACCUs that you've been issued to date. And I'll quickly just click through, pardon me, through this graph. It's the same process over and over again. So you would need to have another sampling round at some point during that reporting period. You then get the data, write your offsets report, submit it to the regulator, and we issue the credits. And I will just briefly mention that as part of that eligibility assessment of your project, you must have a land management strategy, which includes information about how you will maintain the sequestered carbon, pardon me, in your soil for that permanence obligation period. There is this period between K and L where the project activities are expected to continue, but as the crediting period has finished at J, there will be no further ACCUs issued for that time unless there is a review of the method and it's determined that it can continue. And that process is done by ERAC. So, pardon me, just the final word on dates. If the project is declared on the 14th of February in 2022, it's expected that this project will likely continue until the 14th of November 2052. So you'll be issued for 25 years worth of credits, but the project activities would have to continue until for 30 years and 9 months. And that's about it for me. Sorry, I went a touch over time. If you have any questions, you can contact us there.
Thanks so much, Luke. We have had lots of questions come in for you actually through your talk. I think there's a lot of detail in that presentation. Looking forward to unpicking a few of those details during the panel session. But we are going a little bit over time, so I'm just going to pause there and introduce and welcome our final speaker who's been patiently waiting for his turn. So we've got a farmer, David Allen. David's from the Corangamite region in southwest Victoria. David runs a beef, wool and cropping farm that has been in the family for 116 years. David's been involved in land care for around 30 years and is currently running a soil carbon project on the family farm. David's property is also a McDonald's flagship farm, which might tell us a little bit about, the only one in Australia. So welcome, David, and thanks so much for joining us today to talk about your experience, farmer experience of undertaking a soil carbon farming project.
Thank you, Rachel. Can you hear me okay?
Perfect.
The internet has been a bit wafty today, so I hope it don't drop out, but I'll continue on anyway. So thanks for that introduction. We're on Djapurong country down here, and just across the creek is Kirrawurrung country. So we certainly acknowledge all the past history of the Indigenous folk in this area. We've got a soil carbon project. We began that process in the year 2020, and it took basically nearly a year to find a project developer and build a case, and then do all the mapping and identifying the carbon estimation areas, which the other speakers have touched on. So then we were finally granted a project in February 21. And then we could begin do our baseline testing, so which involved so the carbon estimation areas is broken up into minimum of three strata, and there's got to be 3 drilling sites, 3 core samples per strata, and there's a minimum of 3 per CEA, carbon estimation area. So there's minimum of 9 holes per carbon estimation area. And that's based on sort of soil type and land use and things. So with that, we've taken out the gullies and the trees and the buildings and those types of things, and you end up with a reasonable sort of area that can be managed, basically. So we've ended up with a bit over 100 core samples over our. We've actually got 4 sort of blocks of land that we've included in this project. And then it's also been, Sam and Luke mentioned the additionality aspect. So we've had to demonstrate that we are doing something over and above what we normally have done in the past as normal management. And in our case, it's compost. So using compost as a soil amendment. So we either make our own or we buy in a waste product from nearby. So that's our additional sort of management. And then the other aspect that Luke certainly touched on was the permeability of it. The sort of, it's 100 years basically, but they brought it back to 25. But the Clean Energy Regulator do take a percentage of the ACCUs as sort of insurance for that. So we've done all our baseline testing. We've got all the data, and the results. Sorry, the core samples are 0 to 90 centimeters, and it's split into 3. So 0 to 30, or they've been basically 30 to 90. And as Beverly sort of mentioned, the top 30% is sort of 80% of the carbon, and the underneath from 30 to 90 is sort of 20% of the carbon, the soil organic carbon, which sort of correlates with our results, because normally our soil tests just for agricultural purposes are sort of 0 to 10 centimeters, and they run at about 4.5% carbon. But in this case, with these tests, the 0 to 30, the results, because it's deeper, have spread that measurement down from sort of 1.3 to 1.8%, and then 30 to 90, it drops down to sort of 0.5 to 0.8%. So in terms of tonnes hectare, that's sort of around 100 to 193 tonnes per hectare that we've identified and have got. So then, as has also been mentioned by Luke and Sam, the 5 years, before 5 years is up, we've got to do our second test. So that'll be coming up in a year or so. We've got our project developers who are working with us, and we'll do a test site this year. A bit later in the year, or we might get Sam and use this technology. That'll be pretty nifty to see how we're travelling in terms of how much carbon we've got. And as the baseline samples were all tested, and the samples were sent away and all properly assessed and measured and all audited, and the same will apply with the next test as well. They'll all be audited and ticked off, and then having done our second soil testing, we'll then send the report off to the Clean Energy Regulator, and hope Luke's still there, and hopefully he can tick us off if we stay friends with Luke. So no, I'm sure it's a bit more complicated than that. So it is fairly prolonged. It's a long, it's a big process. It's an expensive process, and by continuing just putting compost out is not cheap either, sort of thing. So that's this process of hoping to build soil organic carbon is not exactly cheap. It's not easy. But what we have going for us down in this part of the world that Beverly mentioned is high rainfall. We're 600 mils plus, and we've got a lot of clay soil. So that certainly helps our process. And we've also used a fair bit of rotational grazing. We've got plenty of grasses, so we're fairly confident that we can build a bit of soil organic carbon. And so that's sort of about all I've got, really. That's our farmers' sort of story of a soil carbon project.
Thanks so much, David. And yeah, wonderful to hear about your journey so far, and really good luck with building those soil carbon levels. So thanks to all our speakers for your really excellent presentations. I'm really excited to get into some of the questions now. So the first question I've got, which I'll go to Beverly first, but Sam might want to jump in on it as well. So what are the specific management techniques to build stable organic carbon deeper into the soil profile? Beverly, if you'd like to have the first crack at that one.
Thanks, Rachel, and thanks for the question. It's a really important question, actually, and not an easy one to answer. So the amount of soil organic carbon that you can build depends a bit on what's there already and your past management, as well as the climate and soil factors that I mentioned earlier. And so one of the highest rates of gain in soil carbon that occur is when you start with a soil that's run down, where you have a low initial starting point, and you can build soil carbon. So you may remember from the graph I showed that it will increase fairly quickly there. So the balance between inputs and outputs is what we think about, and you need more inputs than losses. And you get that by maintaining ground cover. So one of the, either a cropping or a grazing situation, you want to make sure that there is minimal periods where the bare soil is exposed to the atmosphere and the bugs are free to break down the carbon and it's lost again to the atmosphere. So that's one of the points. Another point I'll make, and I will give Sam a turn as well, is that one of the limitations on being able to build soil carbon is the availability of nitrogen. So I don't know, it wasn't very obvious and I didn't have time to really talk about it much, but stable soil carbon has a higher nitrogen to carbon ratio than fresh biomass. You need nitrogen in the soil. So using legumes in a pasture mix or in a rotation for crops is a really good way to build soil carbon. So, apart from that, it's just, I suppose, maintaining the soil structure as much as you can within the limitations that our variable climate throws upon us every now and then, and ensuring that there is that healthy production there. And nitrogen is an important part of that. So I'll hand over to Sam, and I can come back if needed.
Thanks, Bev. I don't think I have much to add. Look, I think from our perspective, I mean, the only thing I have to add is, and I would like maybe to throw across to David, because David, you're doing this as well, but soil across the landscape is not homogeneous. You don't have the same soil type, generally speaking, across your farm, right? So in that sense, courses for courses, do what's going to work for your different soil types and understand that and map your soil, and use something like FarmLab to map your soil, or we don't care if you don't use FarmLab, but certainly map your soil, and then you'll have a good idea as to what works where. Take a few soil tests, understand where the weaknesses are across the property and where the improvement can be made. And yeah, David, I might kick across to you because you're doing this in reality. What are you doing to increase carbon? Where?
Thanks, Sam. Yeah, good question. Look, I should have also mentioned dung beetles. I just love dung beetles. They're amazing critters. So they can really transport nutrients deep into the soil, 60 odd centimetres down into the soil. But primarily it's rotational grazing and perennial grasses where there's a root the idea is to get the root down as far as you can. So what's on top of the ground is also what's below. And when a cow comes along and chomps the top third of the grass off, the bottom third of the roots die, they senesce. And then you can move the cattle on to the next paddock and the next cell, and the grass will grow depending on the time of year, and the roots will grow. So that cycle of sort of eating the top and then moving them on really encourages the plants to grow, but also the roots to grow. And when the roots die, that is just sort of basic carbon locked up in the soil, and the deeper you can go, the better. And particularly, below 30 centimetres. So, that rotational grazing process with perennial grasses is one of our main things to use, I think. And not forgetting the dung beetles.
Rachel, if I could just add to, and I really appreciate David's insights there. That's excellent. That there are a number of studies that show using a diversity of plants is also useful.
Yeah.
Wonderful. And dung beetles. So yeah, really good call out for the dung beetle there. Thanks for that, David. The next question I'm going to go to is from Susan Sweeney. So Susan's asking Sam, do your calculations, Sam, mean the farmer can be carbon neutral as well as sell carbon credits? And this is a pretty important question, I think.
It is a really good question. I had a look at this earlier in the chat. Because Luke will, I'll stab Luke in a second, because he had some 3 really good graphs which explain this really well, right? So the answer is yes, you could, but you wouldn't be selling all of your carbon offsets to the regulator or to an international buyer, right? So what the amount of carbon offsets that you build is based on the change in your baseline of emissions. So we look back, is it 5 years, Luke? 5 or 10 years? What is it now? 5 years? 5? Great. Yeah. So you look back 5 years and look at your emissions over the last 5 years before you entered that project, say 1,000 tons of emissions across your farm. And then if you're in 3 years' time, if your emissions have gone up to 1,100 and your carbon sequestered is 2,000 tons, you don't subtract the full 1,100 tons of emissions. You only subtract the 100. Right, because you're doing something slightly different, and you have to remove that slight difference. So we work on human-induced, climate change factors here. So we're only trying to encourage a change, all things remaining the same, including your on-time emissions and your business emissions. Right. So what you would have to do in that case is, rather than selling the 900 credits, which is 1,900 credits to the on the open market, you take the full 1,100 credits out of the equation, you call yourself carbon neutral, and you'd still sell your 900 credits. Doable, certainly, when we calculate carbon across grazing operations. I don't know, 1,000 hectare grazing operation, 300 head of cattle might have 30,000 tons of emissions, but you might be sequestering 100,000 tons of carbon, and so it's kind of that 30% range, carbon sequestered versus carbon emitted. Based sort of, we don't have enough data yet, and it's building, right? So don't take that at sort of direct face value, but certainly the amount of carbon you emit is usually, generally speaking, significantly lower that you can actually do this. It just takes away from the outcome, and you really don't know until that year 3, 4, 5 when you actually sequester that. Luke, have you got anything to add to that there on the baseline front?
Yeah,
are you seeing the baselines go up? I mean, I'm keen to know in general, do people usually have a baseline increase from their baseline when they're sequestering carbon for these projects?
It depends. The first thing I just want to jump in on is that if your 5-year average is 1,000 and it goes down from the implementation of a new activity to 800, you don't get credited for that buffer of 200 either. This method in particular only credits the sequestration that's measured in the soil. And if you're finding gains in the abatement of the emissions that are being avoided from doing your activity, you're not currently credited for that. So it's only the increase is a negative, but any decrease is unfortunately still just negated as a 0. As far as what am I seeing? Not a great deal. There was a bit of a problem with the 2018 method, which means that there's been some delays to information being filtered through to the CER at the moment. A lot of projects, or all projects who are on 2018, will need to move across to 2021 to calculate their abatement. And I did see a question about timing, and a function of the project is that you can change your start date by 18 months from when it was declared. So, realistically, we could see close to about 8 or 9 years before a project is registered and carbon credits are issued. So my expectation is that the CER will see an influx of some of the older projects being reported soon.
Thanks very much, Luke and Sam, for those answers. I've got another one just while you're there, Luke, and ready and unmuted. So this question about permanence. So how's the ERF consider long-term storage and permanence for soil carbon beyond 25 years? What happens at the end of a 25-year project? I know we probably haven't come up against any yet, but what will happen to these projects?
Yeah, it's a good question. So when I talk about a 25-year permanence obligation period, that is one option. And that carries a 20% discount in the credits that you're issued. You can decide to have a 100-year permanence obligation period, which doesn't carry a 20% penalty. The expectation is that the activities will continue for the entirety of the permanence obligation period. And after that obligation period has ended, there is no further obligation to continue those activities. I also briefly mentioned that there is a mechanism that as method activities get to the end of their crediting period, it's possible that there is a review of that method to see if the accrediting period would be extended. So that would need to be taken into consideration when those projects reach that 25-year crediting period end at that time.
Thanks, Luke. I didn't realise that you could have a soil carbon project for 100 years. I sort of thought that they were limited at 25 years. So that's really interesting. Did any of the other panellists have a comment on people's ability to sequester carbon in soil for 100 years?
I think if you're around for long enough, give it a go.
Still digging in the compost. Luke, I just wanted to check with you before please correct me if this is wrong, but I just wanted to note that for the 100-year permanence period, all of the credits are still issued for the 25-year crediting period. So the permanence period, you don't get any further credits for the rest of that 100-year period. You just haven't had the discount before. And that's something that I found is confusing to some people. So I thought I'd just clarify it a little bit.
Yes, thanks, Beverly. Yes, that's correct. So a sequestration project is a 25-year crediting period. So 25 years of credits being issued. And then you can either have a 25-year permanence obligation period or 100-year permanence period. And that was what I was trying to show in that graph with the bars, that there's a slight lag in the length of that permanence period over the extended end of the crediting period alone.
Thanks very much for clarifying that, Luke, and also Beverly. It's good to know that people won't be willing carbon credits to the next generation as they go down. I'm going to go to David now. So David, I'm just wondering, with your project, and starting it out on your farm, would you recommend other farmers get involved in soil carbon projects, and what sort of things should they be considering?
Yeah, look, I think it's good because basically all we're doing is building soil organic matter. The name of the game is to build soil organic matter, which is good. It can only be good. It's like a good veggie garden, if you're putting your soil organic matter, building that up, you've got more water holding capacity, more resilience, etc., etc. There's grass growth, and then therefore more beef cattle. So we're coming from it from the angle of building up our soil organic matter and just trying to create better soil profile and improve the soil quality and microbes, etc. If there's a trade-off with carbon down the track, it would be good. It'd be a pity having gone through all this work not to get a benefit. So that's why we actually registered the project. So we're doing the compost and we're doing the best we can to improve our soil profile. And if we can get some soil carbon benefits down the track, it'll be a real bonus. We're also involved in the Coles carbon neutral branded project. So just in terms of that question earlier by Susan Swanee, I think so while we're not carbon neutral ourselves yet, there is a hope that one day we will be we can be carbon positive, and as Sam says, then we'll we'll allocate our emissions per year, and we'll sort of lock that up, but then we should be able to sell the rest. But our idea is to put it back into the supply chain, and so when we sell our cattle, we'll get X amount for meat, and then we'll get X amount for the carbon credits, because the ESG issues of corporate all over the world is really, really important for them. And it's something that I think we as landowners can tap into, and that also goes along with the biodiversity. And we're using an insetting program with Coles to map and monitor our vegetation to identify the sort of carbon we're sequestering there. So that will offset our emissions that we've currently got, and ours are 11.8 kilos per of CO2 equivalent per kilo of live weight cattle. So they've done it, brought it back to a per kilo basis, and it's something that's quite manageable, I think, and it can only be good news down the track.
Fantastic, David. It sounds like it was a very involved financial decision that you've sort of engaged in.
Combination of sort of just good science and good management, really, and just being aware of what the corporate Australia is really after. You know, where this ESG track is taking us.
Fantastic. Thanks, David. I'm going to go back to Luke now. So I've had a couple of questions that are related to methods and development of new methods. So I've got a question here from Cameron. So are new methods in development? So I'm thinking about, so this is in relation to whether there's a method for the rangelands where the scale of the landscape makes physical soil carbon sampling pretty cost prohibitive. And it's about, can anyone develop a method? But there was also a question that was about the integrated farm management method. So I'm not sure if those two are related, but if you could give us a bit of an overview of what's happening in the soil carbon method development space, Luke, that'd be fantastic. Thanks.
Yes. So within the CER, there is the method development branch. So the previous minister handed down their priorities for the 2022 calendar year. They were published on our website, and one of them was that integrated farming management method, which was looking at the potential of having a single project with multiple methods on that landscape. So for example, soil carbon methods and the potential to have others that overlap with perhaps, I don't know, tree planting or emissions avoidance methods for beef herd. So that work is predominantly done by a separate branch, and they have communications that come out every so often, and all of their methods that they do implement or recommend are generally done through a co-op design process where we go to industry, we ask for their input, and then they take all that feedback away and see what's reasonably able to be implemented. And then a first cut of the draft is put out for public consultation. Generally, the method development branch try to get those methods that they start completed within a 12-month period. So there is some information on our website about the method development branch and their current priorities. And if you want to be involved in some of that co-op design process in the future, you can get in touch with them.
Thanks, Luke. I think there's actually a technical workshop on the integrated farm management method that's happening this Thursday. So if people are interested and have skills and expertise in that field, they can email and probably still be invited to that workshop, which I think is happening this week.
Not quite. They're not. The cutoff was a while ago, so unfortunately not for this round of co-op development, but for sure for the next time that we have around.
Yeah. Thanks, Luke. Sorry, I was giving you a promo, but unfortunately you've missed the deadline this time, so stay tuned. So thanks very much for your answer to that one. So the next question I've got is about about sort of more natural soil carbon sequestration. So to what extent does increasing naturally occurring biodiversity, flora and fauna through holistic re-veg improvements or otherwise help to sequester carbon? So they've got some examples about engineering by wombats and bandicoots in terms, I suppose, of soil turnover. It might be one for Beverly.
I'll do my best to start it off, but I'd welcome David probably has actually some on-ground experience in this, particularly through dung beetles. So the natural systems do tend to reach a steady state or an equilibrium soil carbon level that's determined largely by the type of soil and the climate conditions. I mean, it varies from the year to year, of course, with seasons, you know, with droughts and things like that. Within that scope, though, there's good evidence that you know, the richness of the ecosystem and the way the ecosystem functions works hand in hand with the soil. And it's hard to separate out one from the other because they depend on each other. And managing their natural systems so that the soil carbon gains, if there is a change that occurs naturally, is not something that can be counted in either our national inventory or as a soil carbon project. So I guess maybe theoretically, if you introduced a whole lot of bandicoots to an area, it could be termed a human activity, but I think it's probably not on Luke's list. So having said all that, anything that we can do to improve ecosystem health is a good thing, and it will theoretically, at least potentially, increase soil carbon. So it's sort of hard to say what we can do in a natural system other than to do our best to maintain the soil carbon that's there. The risk is that when what we do as humans can risk losing the soil carbon that naturally occurs in those systems. So I think that's the most important thing. We should be conscious of the fact that there's always a risk that we can turn that balance between inputs and losses that is naturally in equilibrium in a natural system, that we can tip it towards higher losses. And that's essentially what's happened through agriculture in the past, that we've depleted soils of carbon through converting to more tillage, etc. So I don't know whether anyone else on the panel would like to add to that.
There is probably, I mean, we're not in the scientific literature, but we do have lots of data. And in what we see, so we do have clients that will test a, back paddock that's been left, that hasn't been grazed in umpteen years or has just been revegetated. We will consistently see in the top soils, the 0 to 30 centimetre soils at least, and this isn't the mechanism for increase, we don't know what that is, but we are saying that left alone soils will regenerate, and it's between 1% and 4% of an increase is what we see across Australian soils, across the east coast at least. So I think, mechanism aside on how that's being done, certainly destocking and leaving something to regenerate to its native levels will have significant effects. See, Luke won't give you any credits for it because you haven't done anything, but if you want to do the right, and the trade-off is economic at the end of the day, right? I mean, yep, you're locking that paddock up, it will regenerate, will sequester carbon. You obviously have to manage weeds and everything, but it will be more than likely. We see from our clients at least a significant increase versus the grazed or the agricultural land on that farm.
Thanks very much for that, Sam. I'm going to ask one final question, and it's going to be Fauzia's question because she was the brave first person to put her question into the Q&A. And then I'm going to go to all our panel for final comments. So we probably might end up a couple of minutes over time, but I'm hoping that's okay. We did start a few minutes late, so I hope everyone can hang around for that. So the question I did want to ask you, Beverly, that Fauzia put up was, which method did you apply to determine the soil organic carbon that was in your presentations, I think? And if you could provide details of the measurement, that would be great. Not sure how confused that is. It might be something that you'd like to send out, and we can send it onwards, or you can have a go at addressing that now.
I could provide the detail to you, Rachel, and you can forward to anyone interested. But because I cited a number of different studies, the method of determining soil carbon was not always consistent, particularly in the meta-analyses. But the constraints on that is that in each case, we tried to look to only studies that measured down to 30 centimetres, so not just the top 5 or 10 centimetres. And that's because the 0 to 30 centimetres does give you some better idea of the stable carbon, and it's the requirement under accounting for international and national reporting and under the projects for the Clean Energy Regulator. So that's that's one constraint on it. And mostly those studies did use in-field sampling and analyses, and probably analyses in the laboratory. There may have been a couple that used proximal sensing, so spectrometry, like near infrared, but mostly it was the dry combustion or dew-mass combustion method that's used for carbon and nitrogen analysis. And that's probably the most expensive, but the most accurate method still. Although there are the newer mapping techniques that Sam talked about are really looking promising too.
Right. Thanks so much for that, Beverly. So before we finish, I'd just like to go to all the panel members individually and ask you one final question, which is this, it's about regional NRM organisations. They're our primary audience. As I mentioned at the start, we are the peak body for regional NRM organisations across Australia, and regional NRM organisations work with farmers and other land managers across the country to try and improve environmental and sustainable land use outcomes. So if you were to give one final take-home message or piece of advice to our regional NRM organisations about soil carbon sequestration, what would that be? And I might go to Sam first.
Sorry, just answering a question in the Q&A form before we go. I think my final takeaway is I think regardless of your view, I think measure what you can, because we are where we are today. We are where we are today because we do not have sufficient measurements and we do not have sufficient evidence around what mechanisms work. And this whole carbon thing's taken us by storm really the last 2 years, right? If we had better data, we would have better insights. And I think the challenge has been we just don't have enough measurements, and we'd like we need that. We need that evidence. We need to see what's working. We need to see what isn't. But it starts with the land manager and the farmer. So make sure you've got those measurements. You've got them in your back pocket. If you don't enter a carbon project today, at least they're there for future generations, and you can start to piece together the puzzle of what is happening across the landscape, both environmentally, not just soil carbon. Think outside the box. Think biodiversity. Think plant, water. Think everything.
Yeah, great. Thanks, Sam. And I might go to David next.
Okay, thanks, Rachel. Well, I'll hang on the NRM sort of view and take a slightly different tack, and with a quote. And this call of the reed warbler resonates deeply, penetrating my soul. That's the last sentence in Charles Massey's book, Call of the Reed Warbler. And while it was a personal message to him to listen, I think it's a message for all of us, and particularly the NRM people, to listen to the landscapes and be more aware of what we're doing.
Thanks so much, David. That's a really lovely thought. I might go to Luke next for his final thought.
Yeah, thanks, Rachel. touching on what Sam said, more data means more data. We can then start to think about modeled approaches. I went through measurement to measurement in my talk, but there is the Schedule 2 that's part of the 2021 method, which is the hybrid, which has a slight reduction in the amount of sampling that's required, provided that you have a validated model for the amounts of carbon that's being sequestered in your carbon estimation areas. A key takeaway is that if you are interested, it's a voluntary scheme with quite a bit of regulatory framework that's around it. So there's no barriers to you wanting to do it yourself, but there are people that can assist you, including us at the CEA.
Thanks very much, Luke. And I'm going to go to Beverly. I'm also just going to remind people that I have put the link to the survey into the chat. So if you could do that before you go, but I'll go to Beverly for her final thoughts from the conversation today. Thanks, Beverly.
Thanks, Rachel. And bearing in mind that this is an NRM audience, I think the fundamental importance of organic matter content of soils for both natural ecosystem functions and for agricultural system functions just is paramount. And we do need better understanding. I mean, from a science point of view, I can always say we need more research. That's what scientists say after all. But what we mean by that is we need a better understanding of both the particulate and the stable soil carbon fractions, how they work, how we can manage them better. And in NRM situations, it's observing what works and understanding that particulate organic carbon cycling for productivity is equally important to storage. It may not get you soil carbon credits, but the gains for ecosystem health and agricultural system health just is really important.
Thanks so much, Beverly, for that final thought. And I'd really just love to thank all our speakers today. It's been really fascinating, and I think everybody, all of the presentations you gave came together really well to tell a really holistic story of what people are trying to achieve with soil carbon projects. So thank you so much for that. I'd like to invite all the audience to please take 2 minutes to fill in the survey that I've posted into the chat. It really helps us to tailor these events to make them as useful as possible. If you are registered on Eventbrite, we'll be sending around a link to this recording when it's available. And you can also follow NRM Regions Australia on Eventbrite to see when more of our webinars are coming up, or for regional NRM organisation staff. If you'd like to join the carbon farming community of practice or connect with other areas of our work, please get in touch with me. It's just rachelc@nrmregionsaustralia.com.au. So thanks so much to everyone for coming. Thank you for all your wonderful questions, and we look forward to seeing lots of you again soon. Thanks so much.